reference angles, coterminal angles, and their applications in vectors. So we are given a couple of angle measurements: 300 degree, 150 degree, 60 degree, and 240 degree. So for the given angles, we are looking for reference angles and coterminal angles. So by definition of reference angles, we are looking for an acute angle between the terminal side and the x-axis. And the coterminal angle will be from the initial side to the terminal side. In this case, we are going in the clockwise direction. So we'll draw the angle and then determine where is the reference angle and which one is the coterminal angle. So in the picture, we see 300 degree in anti-clockwise direction will come to the fourth quadrant. So the remaining here is 60 degree. So that is our reference angle. So the reference angle is 60 degree. Now the coterminal is from the initial and terminal. So this is going in this direction. So then coterminal will be negative 60. In the second example, we have 150 degree. It is in the second quadrant. So the remaining will be in this side, which is 150 degree minus 360, which is 210 degree negative. That is my coterminal. Now the reference is this one here. So the reference angle will be 180 minus 150, which is 30 degree. So 30 degree is my reference angle and negative 210 is coterminal. So we have 60 degree, this one here in the first quadrant. So that is our reference angle already here. Now the coterminal will be this one here, which is 60 minus 360. So you get negative 300. That is our coterminal. Now the last one, we have 240 degrees. So this is 240. So the remaining is negative 120 is our coterminal. And if you look at this one, this is our reference angle. So we can just say 240 minus 180. So 240 minus 180 gives me 60 degree. So 60 degree is my reference angle and negative 120 is our coterminal angle. Now we'll see the application. We are given a vector u equals negative 2i minus 2 radical 3j, where I and j are the unit vectors. So we need to write this vector in polar form using all four different ways. So first of all, we know that the Cartesian terminal point in this case will be negative 2 comma negative 2 radical 3. The polar form of the vector is r. Theta we'll find as a point first. So then where the r is the magnitude of the vector u, so that one will be square root of negative 2 squared plus negative 2 radical 3 squared. If you grab a calculator and simplify this one, you'll see that the result is 4. So then we know that the length of this vector is 4 units in here. Now we are looking for this angle. So that angle is, let me call it theta. And we know that theta will be tan inverse y over x. So negative 2 radical 3 over 2. And then we need to add pi with it because we get acute angle from this inverse function, and then when we add pi, so we get in the third quadrant. So when you take a calculator, or if you know some information about the unit circle, so negative 2 will cancel out. So tan inverse radical 3 is actually pi by 3, 60 degree. So pi by 3 plus pi, that gives you 4 pi by 3. So that's the angle you got now, theta. So then what is our coterminal now in this? So the coterminal will be 4 pi over 3 minus 2 pi. So that gives me negative 2 pi over 3. So that's the angle here, negative 2 pi over 3. So now the representation of this point P in polar coordinate will be 4 pi by 3 and 4 negative 2 pi by 3. Now we have to determine another 2. So in this representation, now we are taking the image of P on that side. So if this length is 4 for the vector, so other side will be negative 4 now. So then we are writing here negative 4, and then the angle here is here, which is pi by 3. So we write this on here, pi by 3. This is another representation, and the fourth representation will be negative 4. Now we need to find the coterminal angle of this. So the coterminal angle in this case will be pi by 3 minus 2 pi. So that gives me negative 5 pi over 3. So you got negative 5 pi over 3. So these are all 4 representations of the point P in polar coordinate, and we are done.